Okay, we've talked about R-norm and D-norm. Now I'm going to talk about P-norm. What P-norm does is this. Given a value x, which is that distance there from 0, which is the mean, P-norm of x equals area to the left of x. So it's this shaded area here. So that's quite nice. So given a value of x, let's give it this one here, there's x, and in this case x is negative. We can see that P norm of x equals this area here. This here area. It's this area here. So this is quite nice. I keep on drawing it. Notice how when I'm thinking about it, that's not a very good picture, let's try again. When I'm thinking about P norm, that's better. There's x equals 0. There's a particular value of x. P norm gives me P norm of x equals the probability that x is less than or equal to x. It's where x is a random normal number, random variable. Sorry, had a glitch there. So straight away we can say a few simple ones. That's my value there. What is P norm of 0 equals what? Well, it's the probability that your random variable is less than 0, so this area equals a half because the Gaussian distribution is symmetric. What about P norm of some very large value equals what? Well, let's have a look at that. So here's my axis, there's my Gaussian distribution. Well, we're talking about a value, this is x in this direction. X equals 85 is miles in this direction. So P norm of 85 is the area to the left of 85, which is effectively the whole thing. It misses out a tiny little area to the right, but it's basically approximately equal to 1. It's actually 0.99999 something, but pretty close to 1. It kicks in, or P norm is interesting. If I ask something like this, what's P norm of, let's say, 1.6 equals what? Well, it's equal to the probability that a random normal number, which you normally call x, is less than or equal to 1.6. And that's not so easy to say. There's my Gaussian picture. 1.6 might be there. Ooh, I don't know, from the way I've drawn it, maybe 80 or 90%, something like that. Well, there's only one way to find out what it really is, and that's to use R. Actually, R isn't the only way to find out, but it's the easiest by far. Let's just type it in. P norm 1.6. Well, there we go. Oh, I said 90%, and it's, look, nearly 95%, isn't it? So what that's telling me is that the probability, let me just rewrite that. Let's just say that's 0.945. There's more decimal places there, but we'll just stick with 0.945. What's that telling me? That's telling me that the P norm 1.6 equals 0.945. Therefore, the probability that x is less than or equal to 1.6 equals 94. Equals 94.5% plus some other decimal places. Well, that's great, but let's just verify it. As soon as you see a result like that, your first instinct should be, can we try random sampling and see if we can verify that numerically? So let's have a go. Oops. Bonk. What I'm going to use is some random normal numbers. There they are. And I'm going to ask which ones are less than 1.6. Some will be and some won't be. All these are less than 1.6. There you go. So they're all to the left of 1.6. Let's try again. They all are. They all are. Just a minute. There's one that isn't. You see, you carry on doing it for a long time and eventually you find one that's bigger than 1.6. So what I'm going to do is, instead of counting them all up, look, I might do 100 here, and some will be, and look, there's a few, there's a few falses here, there's a few falses there and there. What I'm going to do, instead of counting them, I'm just going to make a table of these guys here. There we go. And this one says that 6 out of 100 are in fact, it's false that they're less than 1.6, so 94 are less than 1.6 and only 6 are greater than. If I do it again, I get a slightly different answer, 10 and so forth. You see, I'm getting random variability there. So what I'm going to do, instead of just 100, I'm going to make a million, 1e6. There we go. And remember what we said it was going to be, pnorm 1.6. Well, it says 0.945. So what we expect is that times a million are actually going to be less than 1.6. So we expect 945,200.7 to be less than 1.6. And here, look, we get 945,000. Well, instead of 200, it's 181 there, so it's pretty close. It's pretty close. Let's try another value. Let's try another value. Pnorm of, let's say, 0.3. Let's try that. That says 61%, and of course if I do the numerical example, instead of 1.6 we've got 0.3 here. We should be getting 6179, 6173. It's pretty close, and of course it's not exactly right because we've got random variability. Okay, so that's how pnorm works. I better show you the help page. Pnorm, question mark, pnorm, question mark gives you the help, and here it is. We can change the mean and standard deviation if we really want. Lower tail equals true, I'm not going to cover that, and log values, I'm not going to cover that either. So R gives you a lot more information than you need, but I'm not going to cover those other bits. The central thing to have in mind is this. Here's your Gaussian distribution. Whoop. There's a particular value x, and then pnorm x gives the area. Okay, and there you are. I'm going to stop there.